So here is problem 3C from tutorial 8. And the question is to figure out whether the given series converges or diverges using the limit comparison test. And basically, when you look at something like this that has a fraction and a square root, the intuition here is that, well, in the numerator you have n plus 1, in the denominator you have n squared plus 2. So the biggest term is n and n squared respectively. So it's the plus 1 or plus 2 are negligible, and the whole thing behaves like just 1 over square root n, which diverges. So we want to prove that the series diverges. And if we want to prove that the series diverges, basically we can try to compare it with something that we know to diverge. For example, with the harmonic series, right? So here is an idea. So idea, to prove that our series diverges, we want to show that our series n plus 1 over n squared plus 2 is bigger than terms of the harmonic series, 1 over n. Again, so we don't know whether this is true or not, right? So we want to prove this. At least we want to try to prove it. Okay, so we're going to try this. Try to prove. Okay, now if you have an inequality, right? So the left-hand side is bigger than the right-hand side, and we know that. So here n is a natural number, right? So n is 1, 2, 3, and so on. So n is 1, 2, 3, and so on. So n has to be at least positive, right? So both left-hand side and right-hand side are positive. So which means that the inequality, this inequality, so we can just square it because it is a legal operation to square an inequality where the left-hand side and the right-hand side are both positive. So then the resulting inequality is going to be equivalent to the original one. So this is true if and only if the square is, it holds for the squares. N plus 1 divided by n squared plus 2 is bigger than 1 over n squared. Right? Okay, so then again, it is a legal operation to multiply an inequality by a positive number. Right? So this inequality is equivalent to the inequality again. So we don't know if it is true or not yet, but we know that if the second inequality is true, then the original one is also true because the original one is just the square root of this new inequality. Okay, but now we can multiply our inequality by the product n squared times n squared plus 2. And this is a positive number, so, and it is a legal operation to multiply an inequality by a positive number. So we do not need to reverse the sign. And doing that, we will get this. N cubed plus n squared is bigger than n squared plus 2. So we can cancel by n squared, right? So what we get is n cubed bigger than 2. And this is true, is it not? So at least as long as n is at least 2 or bigger, this is true. So true if n is at least 2. Okay, it's not true for 1, but it doesn't matter. So it is still true starting at 2 and all the way on. So it is true for all the n except for finite number. So which means that this inequality, n plus 1 over n squared plus 2 is bigger than 1 over n. So this inequality holds for all n that are bigger than or equal to 2. And since the summation of 1 over n diverges, so these are terms of a divergent series. 1. I mean, if you want, you can change 1 to 2, since our inequality is only true starting from the second term. So this series diverges. It means that the original series also diverges.